Here I'm going to try to explain to myself and to you, the viewer, how the double linked lists work when we're appending a new node. So here we're going to take first line of code where we are assigning node with a value 9, which is an integer in this case, and this will create a new node assigning head and tail. In this line of code right here where it's green, it's assigning to the head to a new node, and as you can see, list was empty. It's comparing if list is empty. If list is empty, which is null, then it executes the first part of this algorithm. If not, then it executes. See, it skipped through the second part. It did not even look at the else portion of this algorithm. So it created the head, assigned, since this is the only node that we have, it assigned the tail and the head to this new node that we created with a data type of integer, in this case, which next pointer points to null, and the previous to null because there's nothing else there in the list. Let's see what happens next. Here we're using trying to append another node to this doubly linked list, and it skipped the first part of code and it went straight to else. Why? Because the list is no longer empty. It's not null. So it made a comparison and sees something in there, creates a new node, and just kind of places it to the tail of the existing list, which is data type, the node with the data of integer 9, and assigns immediately next pointer to that new node we just created with the data value 15. And the data value 15 next node becomes null because there's nothing there, and the previous is not assigned yet. So the next line of code in an else portion of the algorithm, it will assign the new node previous pointer to list tail, which is existing list tail right now. It's called tail because the tail has not been changed yet. We did not change the tail of the list, and it's going to happen further down the list, which is the next line of code. And let's see how it happens. So we have assigned in the previous pointer to the list existing list tail, because tail has not been changed yet, which is the node with a data value of 9. And now we're proceeding to the last, where we're going to finalize this list with pointers of the list, which will assign the new tail to the new node. List equals tail equals new node. Excuse me. And that's it. Here's how it's done.